Hey guys, welcome to brainAttic. So today we have another very interesting and very challenging problem from the topic of differential equations. The question was asked in JEE Advanced 2013. So if you do want to give it a try, you may pause the video now and give it a try. Otherwise, we can continue solving the problem. So the question is a solution curve of a differential equation given like this: x squared plus xy plus 4x plus 2y plus 4 within bracket multiplied by dy by dx minus y square is equal to 0 when x is always greater than 0. This is a very important condition that x is always greater than 0 passes through the point 1 comma 3, then the solution curve, and we are given four options. So this question is more than one options correct type of a question. So let us begin solving the problem. uh, just a minute. So we are given x squared plus xy plus 4x plus 2y plus 4 in product with dy dx minus y square is equal to 0. We'll rearrange the terms to get x squared plus 4x plus 4 plus y x plus 2 and product with dy dx minus y square is equal to 0. So solving this differential equation is definitely easy. The main challenge comes when you have to address all the options. So we'll first quickly solve this problem and we'll solve the differential equation to get the solution curve. So now I can very easily take the term x plus 2 common, and it will look something like this: x plus 2 into x plus 2 plus y dy dx minus y square. This is one approach. Or maybe what we can do is we'll take, let x plus 2 be equal to x and y is equal to capital Y. So I'm defining new variables now, and then my equation will look like something like this: x squared plus xy into dy dx minus capital Y square is equal to 0. Now I can rewrite this as x squared dy. Uh, this will be capital D and capital D y and capital X. So we will have x squared dy plus xy capital dy minus y square d capital X is equal to 0. This is y. Now we have x squared dy plus y into x dy minus y dx is equal to 0. So we can rewrite this as minus d capital Y capital Y is equal to x d capital Y minus y d capital X x squared. So this is very known to us, these expressions, and this is nothing but differential of log mod of capital Y. And this the other term on the right hand side is differential of capital Y by capital X. So on integrating we have minus log of mod y is equal to capital Y by capital X into C. So we know that capital X is equal to x plus 2 and capital Y is equal to y, small y. So we'll put them back in the term and we have minus log of mod small y is equal to y by x plus 2 plus C, integration constant. Now we know that since solution curve passes through 1 comma 3. So we'll use this point to find the integration constant. So this gives us therefore minus log mod 3, positive is log 3 only, is equal to 1 plus C. So one more point which I'm going to be using is all the log which I'm going to write from here onwards will be natural log. So all will be natural log. Okay, log with the base E. Just bear it in mind. Okay. Now, so my integration constant c becomes nothing but minus 1 minus log 3, which is minus log 3e. So my integration constant is minus log 3e. So my solution curve is log mod y plus y by x plus 2 minus log 3e is equal to 0. Just a little more effort and I can rewrite this as minus log y mod y by 3e plus y by x plus 2 is equal to 0. I basically use the property of logarithms. So now we have to check the options. Now when we have the solution curve, we have to check the options. So we have to check whether y is equal to x plus 2 intersects how many times with the solution curve. So that will take care of both option A as well as option B. So now y is equal to x plus 2 is given to us and we have to check how many times it intersects the curve. So we will put the term x plus 2 in place of y in all the uh, in the expression. So we have by 3e plus x plus 2 by x plus 2. So this cancels out each other to give 1 and we have log mod x plus 2 by 3e is equal to minus 1. So then we have mod x plus 2 mod x plus 2 by 3e and here we have e power minus 1. Basically I took the exponent and since my base is e exponent then I can simply put it as e power minus 1. I already said that all my logarithms are with the base exponent, so natural logs. So I have this again is nothing but 1 by e. So mod x plus 2 is equal to 3. So I have two solutions now. One is x is equal to 1 and the other solution is x is equal to minus 5. Now, in the question, I told you if you recall that x greater than 0 is a very important point. So it has only one solution. X is equal to 1 is the only solution. So my option A is correct and option B is not correct. Now, going forward for option C, we'll check option C. So, in option C, we are given y is equal to x plus 2 whole square. So, we'll make the same approach and apply. We'll have 3e is equal to, sorry, my bad, plus y by x plus 2 is equal to 0. This is my solution curve. Now, I'll apply the term x plus 2 whole square in place of y throughout the expression plus x plus 2 whole square by x plus 2 is equal to 0. So I cancel out and I'm left with minus x plus 2. So taking the same approach quickly, x plus 2 whole square. Since it will always be a positive term, mod will always be positive. So I have minus x plus 2. Now this gives me x plus 2 whole square is equal to by 3e is equal to e power minus x plus 2. Finally, x plus 2 whole square e power x plus 2 is equal to 3e and therefore e power x plus 2 is equal to 3e by x plus 2 whole square. So we'll take an approach here. We'll see how this graph will basically look like. So if I'm given the equation y is equal to e power x plus 2, then if I put the value of x as 0, then we get a point something like e power 2 over here. And as the x value increases, this graph will only go upwards. Okay, because this will always be a positive term and the graph will keep on going upwards. And in the second expression, y is equal to 3e by x plus 2 whole square. If I put the value of x is equal to 0, I will get a term e power 3e by 4. Very clear, right? This term 3e by 4 will definitely be less than e square. So this will come somewhere, I'll put it down here. And as the value of x increases, the denominator value increases and the numerator is constant, and this value will keep going down. So there is clearly no solution. Clearly, they have no solution. Again, one thing very important to keep in mind is that x is always greater than 0. This condition is given to us from the question itself. So they don't have any solution. Now going back to the options, this is not applicable. And finally we go to our final option which we have, that is D. So we are given y is equal to x plus 3 whole square. Okay, now again applying it quickly to the term mod x plus 3 whole square by 3e plus x plus 3 whole square by x plus 2 is equal to 0. So, so we'll take a different approach now. Let gx, let me write this down. Let gx is equal to 2 log, and since x plus 3 whole square will always be positive, I'll simply remove the mod and take the square and bring it in front using the properties of log, minus log 3e plus x plus 3 whole square by x plus 2. This is my expression. So gx is this. Basically what I did, I took the first term, I announced it as g of x. G of x is equal to 0. Now if I take g dash of x, g dash of x will be equal to 2 by x plus 3 minus 0 plus uh, x plus 2 2x plus 3 minus x plus 3 whole square into 1 by x plus 2 whole square. So this term is clearly with x greater than 0, g dash of x is clearly greater than 0. Therefore, gx is increasing with x greater than 0. So there is no solution similar to this approach what we have here, right? I took another approach to show you, and there is no solution. So option D is correct. So we found our answer that option A and option D are correct. If you do like the video, hit the like button, subscribe to our channel for more content like this. If you have some suggestions or recommendations or some more problems which you want to get solved, please do comment. Thank you so much for watching.